Dear class, sorry I cannot be here today, and we are going to chapter 2 as we're going to talk about equations, inequality, and problem solving. We'll start with section 2.1 first. Section 2.1, we are going to talk about solving first-degree equations. The method is isolating a variable. And first-degree equation usually also referred as linear equation or line equations. So here we're going to talk about how to solve first-degree equation by isolating a variable and use equation to solve a word problem. Probably today we're just going to focus on item number 1. When we refer to equations usually just a statement. Okay, the statement is either true or false. For example, this equation 3 plus negative a equals negative 5 is true because 3 minus 5 is negative 5. However, the next equation negative 7 plus 4 equals to 2, it's a false statement because in actuality negative 7 plus 4 is negative 3. So make the previous statement a false statement. Next, we are going to talk about what is an algebraic equation. An algebraic equation contains either one or more variables. Here, the following example are algebraic equations, all of them. Some contain, let's see, one variable like x here, or only one variable y here, or some contain two variables, x and y. Okay, so this all are algebraic expressions or equations, if you like. So an algebraic equation such as 3x plus 5 equals to a is neither true nor a false statement. It all depends on the value of x, and we often refer it as an open sentence. So each time a number is substituted for x, the algebraic equation 3x plus 5 equals to a become a numerical statement that is either true or false. For example, if x equals 0, then we replace x by 0. We have 3 times 0 plus 5 equals to a. Well, is that a false statement or not? Actually, it's not, because 3 times 0 plus 5 is 0 plus 5, which is equal to 5. Obviously, is not equal to a. So make this, if x equals 0, we'll make this statement a false statement. However, if x equal to 1, then 3x plus 5 equals to 8 become 3 times 1, which is 3 plus 5 equals to 8, which is a true statement. So what does it mean by solving an equation? It refers to the process of finding a number or numbers, you have more than one variable, that makes an algebraic equation a true statement, a true numerical statement, if you like. And we'll call such solutions, such number that make this equation a true statement, the solution or the root of the equation. And we say that it satisfies the equations. And we call the set of all solutions of an equation, it's a solution set. So in the previous example, the number 1 is a solution to this equation, 3x plus 5 equals to a, or we can say 1 satisfies this equation. And this little bracelet is a notation for a set notations. So here we will consider technique for solving first-degree equation in one variable. So this means that the equation contains only one variable, and that this variable is an equation of its exponent of 1. And the following are example of the first-degree equation in one variable. So notice that the exponent of x is equal to 1 was one variable x in the first equation. Second one, although there's a 2/3 at the coefficient, the power of y is 1, therefore is first degree. So is this one. Although you have 7a on the left, 3a on the right, you can do some algebraic maneuver to make them together. We're going to talk about this later. However, the most power you have for a, the variable a, is 1. Even though this looks very complicated, but if we focus the exponent of x, both are 1 on either side. Therefore, all 4 equations are first-degree equations. Next, we are going to introduce what is called equivalent equations. Equivalent equations are equations that have the same solution set. For example, the solution of 3x plus 5 equals 8, which we did a while ago, the solution is 1. So is equation number 2, 3x equal to 3. If you replace x by 1, you get a true statement. The left-hand side is 3, the right-hand side is 3. X equal to 1, obviously explains itself. So all 3 equations have a solution set that are 1, therefore they are equivalent equations. And that is equation 3 is equivalent to equation 1. 3 is equivalent to 1. Therefore, x equal to 1, that's the simplest form you have, is a solution for what? For 3x plus 5 equal to 8. Also, x equal to 1 is a solution for 3x equal to 3. So the general procedure for solving an equation is to continue replacing the given equation with the equivalent but simpler equations until we obtain an equation of the form x, a variable, equal to constant, or constant equal to variable. For example, what we just showed you. If we know 3x plus 5 equals to 8, then we can subtract 5 on both sides, and we obtain an equivalent equation, which is 3x equal to 8. Then by continue isolating x, we can divide both sides by 3. Now, then we obtain x equal to 1. All 3 equations are equivalent equations. However, the most right equation tells us the solution to the left, a slightly more complicated equation. The solution is x equal to 1. That is, x equal to 1 will make this equation a true statement. So to solve equations, we need to use various properties of equality. And the following equality, you probably are familiar with it. Let's just formally recognize them. Additive property of equality, meaning if you add the same number on both sides, your equation remains true. Meaning if x minus 3 equal to 5, then if I add 3 on both sides, that is the same equation. But however, you can see where are we going with this. If x minus 3 plus 3, then you can cancel the negative 3 and 3. The right-hand side, 5 plus 3 equals 8. You obtain what? X equals to 8. So you can see adding the 3 is strategically try to cancel out the negative 3 here. Also, we have multiplication property of equality, meaning you have 3 number, just make sure C is not 0. If A equals to B, then A times C equal to B times C. Of course, C can be 0 because anything times 0 equal to 0 anyway. So, for example, 3x equal to 9, not will strategically multiply both sides by 1/3. Why? Because 1/3 times 3 equals to 1. We get x on the left. However, right-hand side now give us 3. And this x equals to 3 is a solution of 3x minus 9. So solving a complex equation just simply involving doing a bunch of maneuver of additional property and multiplication property. Repeat what we're just showing you a while ago. The addition property of equality states that when the same number is added to both sides of an equation, an equivalent equation is produced. That means they have the same solutions. However, a multiplication property of an equality states that we obtain an equivalent equation whenever we multiply both sides of an equation by the same non-zero number. Well, we just showed you a while ago, 1/3 times 3x equal to 9. Now we get 1/3 times 9, which is 3, the left-hand side equal to x. Then we subsequently solve these equations. And the following example demonstrates the use of these properties to solve any equations. Equation 1. We try to solve 2x minus 1 equal to 13. So remember, the method is called isolated variable. So first you want to move everything, nothing to do with the variable, to the other side. So what can we do is to get rid of -1. You can add 1 on both sides. So we want to simplify. Don't forget, our goal is to simplify the equation into just x equal to some constant. So we add 1 on both sides. Now the left-hand side, you only have 2x left. So that's simpler than original look. But now, how do we get rid of the 2 here? Can we multiply both sides by 1/2? So make the coefficient 1 here. Well, as a result, we multiply by the reciprocal of the coefficient, which is 2, and the reciprocal is 1/2. Therefore, 2 times 1/2 equals to 1. On the left-hand side, we will obtain x. However, the now right-hand side is 7, and the solution set is 7. Well, we solved the equation. We did everything correct, but you wonder, hey, is our answer correct or not? So is 7 the solution to the equation? And yes, you can check it by plug it back in, or replace x by 7 to see if you obtain a true statement. Or we can say, this is another way to say, does 7 satisfy this equation? So check. Replace x by 7. Notice I have a little question mark here. The left-hand side will be 2 times 7 minus 1. Hopefully, you'll be equal to what? 13. Well, we'll do some computation. 14 minus 1 is 13. So at this point, if the left-hand side equal to the right-hand side, you can remove the what? The question mark. Now we know for sure 7 is the solution of 2x minus 1 equal to 13. Now, this is just try to summarize the process of solving a first-degree equation in one variable as follows. First, simplify both sides of the equation as much as possible. So we have 3x minus 2 equal to 13. So what you want to do is what? Get rid of -2. So in order to do that, we add 2 on both sides of the equations and use the additional property of equality to isolate the term that contains a variable on one side and a constant on the other side. So what we want to do is add 2 on both sides. So therefore, the left-hand side, you only have what? 3x left. However, the now right-hand side is 15. So step 3, use the multiplication property of equality to make the coefficient of the variable 1. That is, multiply both sides of the equation by the reciprocal of the numerical coefficient of the variable. In our case, it's 3. Therefore, the reciprocal is 1/3. Multiply both sides by 1/3. Now we'll get a simple statement, x equal to 5. You can always check your answer by plug in 5 to the original equation to see if you obtain a true statement. So let's go ahead and do this on the left-hand side only. 3x minus 2. We replace x by 5. And we have 15 minus 2. Then we get 13, which is the right-hand side. Therefore, we know 5 is the correct answer. So we did show you some steps, but don't forget, there's a reason for that, okay? There's a reason for that. So don't just memorize a step. Go back to understand why do we do what we do. Now we look at example. Although we have 6 questions, we are going to show just 2 examples, number 1 and number 4. Let's look at number 1 first. 5x plus 7 equal to 32. Again, the goal is to simplify that. So first what we want to do is get rid of the 7 here, the 7 here on the left. So we subtract 7 from both sides. And then now the left-hand side is simpler with only 5x left. And the right-hand side will do the computation, you get 25. So what's next? We want to make the create a coefficient 1 for the 5x. So we want to get rid of the 5. So to do so, we multiply both sides by the reciprocal of the number of 5, the coefficient of x. Now, 1/5 times 5 equals to 1. The left-hand side gives us just x, and the right-hand side gives us 25. Hence the answer. Now, so let's look at example number 4. 7x minus 5 equal to 3x plus 15. Again, now we have x's on both sides. So what we want to do is isolate x on one side only. Sometimes we call this collect the like terms, meaning we want all the x's on one side, all the constant on the other side. So it's easier for now. Let's take out the 3x on the right. So what we did is, we were doing is subtract 3x from both sides. All right, the red one, we did this. However, 3x and minus 3x cancel out, and we'll combine the 7x and minus 3x become 4x. So now we do the following from example 1. Now we want to get rid of the negative 5 on the left-hand side, so we add 5 on both sides. Now the left-hand side is just 4x, the right-hand side is 20. Now to do the same thing, we want to isolate x, so multiply both sides by the reciprocal of 4, which is 1/4. Our left-hand side is x, right-hand side is 5. That's how we solve a linear equations.